what we are trying to do, and especially this was for the girl child, but we realized that the girl child has been burdened with so many favors until we said now we want to bring also the boy child. So we got 44 students. Actually now there are 46, which comprises boys and girls. But what we are trying to do, because nuclear is knowledge intensive, we want to start talking about nuclear science and technology at a very young age, so that we don't reach the university and then we realize, oh, we don't have people trained in this field. So it's better when you start it when they are still young, and then they can embrace science, technology, engineering, and maths. So STEM is still not being promoted well in this part of the world. But you know how some countries, the so-called developed, have developed is because of innovation and technology. And until we embrace that, and we embrace it right from school up to universities, I don't think we are going anywhere. So we, Nuclear Energy Agency and the International Cooperation Framework for Nuclear Cooperation, IFNEC, we've partnered to be an example in Africa. Actually, we are starting this program for the first time in this region in Kenya. And it's something that we intend to do annually, so that we bring these people together, and then we bring the mentors, those who've done well in science and technology, or any other field, not necessarily science and technology, so that you can see that, if she can do it, then I, as a lady, I can do it. I remember when I was in school, maths was a big issue to the girl child. But I think it's only in the mind that maths is difficult. And maths is very, very strange. If you go that it's difficult, it will be very difficult, for sure. So we want to bring it to the environment where they can see that this is something or a subject or a course that has been done by any other lady, and we can see them around and you can touch them, they are tangible, you can talk to them, and I think they'll get the encouragement from that. We intend to be a middle income economy by 2030. I think you've heard about Vision 2030 Blueprint. Now, Vision 2030 Blueprint had what we call Vision 2030 flagship projects, and some of them we know are being implemented, like the SGR. Then we are talking of the rapid transport system, and now we wanted the light rail in Nairobi, we wanted the economic parks in Olkaria and all that. This is supposed to use energy, and when we did, that's around 2008, they crunched the numbers about what we were using, and we've been over-dependent on hydros. Then we realized that our hydros are running out, even though God has given us a natural resource called geothermal. But then even the potential we have in the geothermal will not be enough to run the industries when we aspire to be to the Malaysias and the Singapores of Africa. And a thought came on the table that we can introduce gas, the LNG, and then nuclear for future. That time the program was very ambitious, and they said by the year 2020, but nuclear takes a long time. In a normal curve, around the preparation takes around 15 years. But it can even take forever. There are some countries who started in 1960 and they're still pursuing nuclear. So we went to the International Atomic Energy Agency, and they gave us a long list of the things we are supposed to do. Maybe you must have seen that 2-3 weeks ago that we did the peer review of what we did in 2015. And then we realized that with all these infrastructure issues, they call them the infrastructure issue of the milestone approach, we'll not be able to achieve the nuclear plant by the year 2020. That time, they wanted in 10 years. And then now we also go back to planning. There's a planning arm of the Ministry of Energy who now do planning in terms of what is supposed to be done in hydros in the next 5 years, what they call short-term, medium-term, and long-term. And then what is supposed to be done in geothermal. And then now when they did the simulation on nuclear, depending on cost and the capacity, because initially we were talking over 1,000 megawatts, and 1,000, a fleet of 4 to make 4,000. But now we wanted to do a shift and see if our grid is not growing to the extent that we can have 1,000, can we have small modular reactors between 500, 600, 700? There are even some of 300. I saw Chinese have even done one of 120. Then when they did this simulation, now nuclear comes in the year between 2030 and 2036. We are okay with that because it takes a long time to prepare. So that's what we have in the plan already at the Ministry of Energy. Yeah. In terms of preparation, I said we use the milestone approach because IEA encourages that member states use nuclear for peaceful uses. And nuclear is a very emotive topic because when you talk nuclear, I think majority of you think about bombs. But that's not what we are trying to do. We are doing it for peaceful uses. That is to generate electricity, to use it in water, to use it in agriculture, to use it in industry, and to use it in health, like what we are doing in Eldoret and Kenyatta National Hospital in radiotherapy. So that is where we are in terms of infrastructure issues. We've completed the phase 1, and we are just about to go to phase 2. That's when it is planned that the first plant should be up. Depending on how hard we work and the resources that are available, we should be able to achieve that. That is achievable. Currently, we can only use the benchmark. Like we started with the United Arab Emirates almost at the same time, but them, they have billions and billions of dollars, and I think their plant of 4,000 megawatts will cost slightly around 450 billion, equivalent of Kenya shillings. I don't know what it will cost in the year 2030 to 2036 because also it depends on what we call G2G. What is the relationship you have between your country and the vendor countries? Like they had a soft landing because Korea wanted to do the plant, and I think Korea maybe gave them what was written. But I really can't say what it will cost in the year 2036. But it's in the range of 400 to 500 billion for 4,000.
The site you've identified in Kenya?
Well, we had what we call the potential sites along Lake Victoria, along Tana River, and along the coast region. And site comes with studies, so we are just about now to commence to zero in on the sites that we have the areas that we've identified in the coast region, so that we can do what we call detailed site characterization, which takes around 3 years. And then we can comfortably say, this is the site that will put the nuclear power plant, and this is the alternate site. Yeah. Okay, in terms of cost, nuclear and hydro and geothermal are almost in the same range in terms of US cents per kilowatt hour. We've had a problem in this country ever since we introduced the thermal plants. That's around 1996 to 1998. I think we had the first thermal plant in 1998, because I was involved in that time. Now, when you check your bill, you find that the fuel cost is even more than the energy, and this is what the government is trying to protect the wananchi, so that we don't have high bills because of the fuel that has been used for generation. So, and I think there's even a policy that they want to eliminate that. Now, the big advantages of nuclear is that it runs at around 98% capacity factor, because if you take maybe a plant of 1,000 megawatts, then you'll run it for 18 months without stopping it. You only stop it for around 3 weeks to change the fuel, and again you run it for another 18 months without stopping it to stop it to change the fuel. So you can easily achieve 98 to 99 capacity factor. The second is that in terms of gas emissions, it's zero. And where the world is heading now in terms of climate mitigation, is being advised that the zero gas emitters in terms of generation should be put more on the grid, so that we can create this climate change mitigation. And I think the third one is that in terms of reliability in supply, then the technologies that have emerged from the nuclear power plants of 1950s to what we call now the fourth generation, the reliability factor is so high that you can count on it to do a baseload generation. It should ideally lower the cost to the consumer. Yeah. And I think we have countries that we can give an example, like France, which is using over 60% their installed capacity is nuclear. The cost of electricity is low. Yeah, the disaster, and you know, sometimes we over emphasize on the disasters because nuclear has been in operation for over 50 years with 3 accidents. But we are not saying that we should have accidents. The first accident was it in 1978 in the 3 Mile Island in the U.S. Then we had the worst in Ukraine. Which was a very bad one because that was in terms of design. Then we had the Fukushima Daiichi, which was because of the tsunami. So actually, we've only had the worst one was the one in the Ukraine where some people died. In the first nuclear accident, no one died. But we are saying that each accident comes with a lesson to learn. And that's why they've come now with the technology that you have the co-catcher and you have the reinforced plant with a layer that even if you hit it with a Boeing 787, nothing will happen. So safety, they take safety very, very seriously. Why? Because nuclear business is big business, and vendors don't want to spoil their name in terms of accident, because we say that an accident here is an accident everywhere in terms of nuclear. Now, if it happens here, then you look at the reference plants around the world. Say, do we have this plant in Malaysia? Say, stop it. Do you have it in Qatar? Stop it. So you'll have stop all your plants until you do the pressure tests and all the tests that you want to do to bring them back. You are losing money, and they don't want to spoil their name. So sometimes we always say that nuclear is so self-regulating because you have very few vendors and they want to continue operating the plants. Accidents are accidents, but what we say, it uses the Poisson distribution curve because nuclear is like an arrow curve. The probability of an accident happening is very, very low, but the impact of that low probability is very high. So if you get it from that point, you know what to do.